Hello everyone, welcome back. Now we are in a position to discuss a new sensor, that is the PCA9536 with a buzzer. Now to gain more knowledge about this sensor, let's visit the website, that is controleverything.com, and here we have to search on for this particular sensor, and let's see what we got here for this particular sensor, that is PCA9536 I2C Digital 3-channel input output with a buzzer, and it's a I2C control buzzer, and you can see more prominent features of this particular sensor, and you can also have the privilege to add to cart or to purchase the sensor right from this website, right from here. Furthermore, I will be interfacing the PCA9536 buzzer with a Raspberry Pi, and the software platform will be a Java code language. And for the code, let's go to resource tab, and here we have the Java code sample onto your screen, and you can download the code sample from this very site as a zip file right from here. And you can also get the code from github.com, and the repository there will be Controlled Everything Community. Now what we're gonna do is to make some hardware connections, and let's see what we got there. Well, in the hardware setup for the connections, what do we require is this Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Next, we require an I2C Shield, which you can see, and it's available on the website controleverything.com. The real reason we are using this shield is to make easier connections with other I2C devices. So for that, gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we need to power up our Raspberry Pi, and for that we require a micro USB cable just like that, and gently insert it over here, the power jack. And for the internet connection, there are two options. First of all, this here is an Ethernet cable or a LAN cable. Now gently insert it over this Ethernet jack, and you are done with the connections part. Now for the other internet connection, we can also have a adapter, a wireless nano USB adapter, just like that, and you can have on the USB port. Next, we need our sensor, that is PCA9536, along with a buzzer. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the ground terminal of the I2C shield. Now we are done with all the connections for the hardware. Now let's have a look over the code, and let's see what we got there. Now let's have a look over the interfacing code, and to get your hands on the code, we need to log into github.com, and after that we have to search on for the repository that will be Control Everything Community. And after that, we have the sensor PCA9536 with a buzzer, and let's have the Java code. But before that, let's have a look over the instructions we need to fulfill. And it says that we have to download and install Pi4j library on the Raspberry Pi, and this link pi4j.com is the official link from where we can download our library and we can install it on the Raspberry Pi. Please do follow the instructions carefully. And then we have to download or git pull the code onto the Raspberry Pi, and this command will compile, and this will run the Java code onto our screen just right. And then get back to Java code. It's a .java extension file. You notice first thing you see into the code that we have imported some of the libraries, and we have created a public class named PCA9536 underscore BZ. Then we have to check for the address of the sensor, that will be 0x41. And as you notice in the writing section part, we are going to write, first of all, select the configuration register, that is 0x03, and writing all pins configured as outputs, that will be 0xf0. Now in the reading section part, we have a for loop which will run 4 times, and here as you notice we are sending a command for reading section. We are first of all selecting output port register 0x01, and we are logic high on each pin. We are setting this condition right here, just like that. And then in the if else condition, we are going to print the data according to the state and the buzzer condition, and it will say input output pin state is high and buzzer is off, whether or not. And the other condition will be input output pin state is high and buzzer is on. So there are two different conditions which will trigger upon the condition of the buzzer according for the sensor. Now this is how the code looks like. Now let's see how it works. Alright, regarding the working environment, first of all we need to copy this entire code of the Java, and after that we need to open up the terminal for the Raspberry Pi, and here we need to create a new file as we are able to see on my screen, and .java will be the extension. And after that we have to paste the entire code, and then we have to save it, And this is the command for the compilation of the code, as you are able to see. And let's see what we got here. It's a .java extension file we are going to compile, and the code is now in the compilation step. The code compiled successfully. Now to run it, when I run the command, we will have some output onto the screen. Please note it down carefully. And it will be output 0, 1, 2 will be high. It means input output 0, 1, 2 state is high, buzzer is off. But when input output pin 3 is there, state will be high and buzzer will be on, just like you heard. Now when I again run the command, and you will notice the output onto the screen. This means the same condition is there. Input output pin 0, 1, 2 has a state high and buzzer is off, and when input pin 3 state is high, the buzzer will be on, which you have seen just right now in front of your screen. So this means the sensor works perfect, and now we have to show some of the applications and some of the benefits regarding this sensor. The PCA9536 is an 8-pin CMOS device that provides 4 bits of general purpose parallel input-output, that is GPIO expansion for I2C-bus SMBus applications, and input-output expanders provide a simple solution when additional input-output is needed for applications like ACPI power switches, sensors, push buttons, LEDs, fans, etc. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.